Recording in progress.
Now let's start with the concept of nets of solids. This falls under the category of mensuration. So basically, we have a 3D object and we open it up, and we have all the faces that are visible, and we can count the vertices, we can calculate the areas and so on. So nets is about this thing, which is mensuration. So that's the official definition. A net of a 3D object is a 2D shape that can be folded to make the 3D object. Just basically consider this as a box. And if you use a cutter and you open up the box, so everything will be laying flat. So a 3D object will become a 2D object. Now let's get started. Let's have a look at this website and let's see what kind of questions do you see. The diagrams. Okay. Now let me look at a cube. First of all, let me just check one thing. That is, okay, it's on the side. I don't know why is it too much on the side here. Okay. Now let me get started. Let me delete this. Diagram is not that visible. Okay, I think there is an issue with this. Okay, now this is better. Let me make it a bit bigger. And this is a cube, as you can see. So now if I unfold it, this is a net. Okay, so that's a net that you see. So I can use something to write, which I cannot over here. So you can see the base, and that is the base like this. Hold for a second. That is another one. Okay, so now if I fold it, you can see the side walls, the front, back, right, left, bottom, top, and it's all becoming a cube. Now let me look at a prism. If I open it up, it's a hexagonal prism. There are 6 sides. The base is the red one, and the orange ones are the walls on the side. And let me remove this. Another prism. So now the reddish one, let me make it smaller. And that's the top, that's the bottom. And then I can look at the different sides. Now, if I open this up, so now you can see that the front, the top and the bottom is there, and the 6 walls are there. And let me just delete this. Now, a tetrahedron, where is it? So now it's hiding somewhere. Okay, so, okay. Octahedron. So 8-sided figure like this. I think that's good enough. So we can just go back and we can look at the different things. Now, these are the images that you see. This is a triangular prism. So basically, these are the sides. This is the bottom. And these are the slant sides. So just imagine that being made into one 3D shape. This is a cuboid, a rectangular prism. So this is like the base. This is side wall. This is side wall. This is the right-hand side. This is the left-hand side. And this is the top. And the same goes with the hexagonal prism. And even a more better diagram. So now you can very well say that these two are exactly the same. These two are the same. This and this are the same. And it's becoming like this. So I think that's a pretty good diagram. So just acknowledge on the WhatsApp if this is all making sense. Okay, now why don't you look at this and try to figure it out yourself? What exactly is this? Yes, it's a triangular prism. So this is that slant thing. This is the slant side. This is the front. And over here will be the back. So one of them could be the front. This is the back. This is the slant. And this is the side wall. So now that's how this is done. Another figure like this. How many shapes are there? How many faces are there? The front and the back, two, top three, four, five. Five sides are there. Also, we can count the vertices because sometimes they ask us the vertices. So this is one, this is two, this is three, four, five, six, seven, and eight. I hope I have not left anything out. There are eight vertices, and that's how the shape is there. So how many faces are there? Six. So there is this one, the front and the back, side and the side, top and the bottom. Yes, there are six shapes. What is this? This is a cylinder. This is the top of the cylinder. This is the bottom of the cylinder. This is the curved surface area, which is rolled out to make a rectangle. And then there are basic questions. This thing is there. Draw a net uh, for the cylinder shown. Label the net with its dimension. So this six, that is one thing. One dimension, radius is one. So therefore the diameter is two. So this is 6 by 2 if they are asking for this. So this is 6 and this is 2. And this is the circle with 1. And find the missing length of the rectangle. It's equal to the circumference of the circle. So this is diameter. Yes, if we fold it, that's the circumference. Circumference is 6.28. It's not 2, it's more than that. The reason being the diameter is 2, but when we roll it out, it's the circumference. So that is something very important. So just remember that. And then there is this exercise. There are answers to this exercise. Similarly, the next one is about drawing it. Now, let's look at this past paper question. Now, this is a paper one question, November 2019, and paper 1-1. So it says the diagram shows the net of a solid. What is the special name of the solid? So the special name is a pyramid. This is the base, and these are the walls, wall 1, wall 2, wall 3, wall 4. So these are the walls of the sides. So W stand for the walls. And this B is the base. So let me just write B over here. Okay. For the solid, write down the number of vertices. So how many vertices are there? This is 1, this is 2, this is 1, 2, 3, 4, and this and this and this and this will make one vertex. They will all join at a point. So the number of vertices is 5. And then this question is about factorization. So let's ignore that. Now, another question. This is about the year. That is November 2020, variant 1-2, question number 14. The net is folded to make a triangular prism. So now the only strange thing is this portion is on the side. Basically, it should go like this. So J is here, K goes with H. So let me write it. K should be with H and J as it is. And basically, this A and B, this is would be touching, B should be touching E. Let me choose a different color. So B should be touching E, and A should be touching Actually, the other way around. B should be touching D, and A should be touching E. Okay, so now imagine this triangular prism. It's difficult to imagine, but that's how it is. Which vertices will join with A? So what will join with A? I think A will join E and A will join G. Let's double check. A will join G, A will join E. Okay, because it is like this figure. So let me grab that figure from upstairs. And I there was this triangular prism. Yes, that's this one. Let me just copy this much. Okay, actually, just let me erase this thing and let me take a screenshot of only this thing. Copy. Okay. So let's go back to this. Okay, now we can see this figure like this. And this side, this is the triangular wall. So this is the side wall, this is the side wall. So that's over here, and that will be over here. And this side joining this thing. So this basically, this EFCD, that will go along this line like this. It will be folded. This will go up. So like this. And this will be folded on this. This will be folded on this. And this will come from the side. So E, G, and A, it will all join together. Which edge joins DE? So DE, which edge will join DE? That will be AB. So first of all, let me write G, let me write E, let me write AB. You can write AB, you can write BA, both are perfect. Find the volume of the triangular prism. That is easy. FH is 2, GH is 2. So FH is 2, GH is 2. So therefore, this is G, this is F, this is H. Therefore, area of this triangle, that's half into 2 into 2. That comes out to be 1 square unit. And what else is there? JH is 5. What is JH? JH is this thing, 5 centimeter. That's the length. So therefore, a volume is cross-sectional area into length. So this half into 2 is 2. So this is 2 into 5. That comes out to be 10 centimeter cube. That's the volume of the prism. So this is 10 centimeter cube. Let's double check. Yes. And that finishes the concept of nets of solids.